Hi. So today the main topic is also the B3, but is actually about the implementation of it. Um, like uh, the problem I faced was the implement it. So I'm kind of a junior, so I because I only have like 9 months experience of working, and most of the student. So yeah, I'm blaming that I have lack of experience. So my issue was the implement first and factor it, and um, and implement and refactor and done. So my like 6 months ago, my problem was I just implemented it first rather than thinking about what's the good code quality. And first now I change as like this: implement, but check the code quality but if the code quality is kind of bad, refactor it. So and implement it and refactor it. So that's really how I did. But the other problem is that there's a kind of like way to I analyze the code quality and refactor it. I just how somehow the analyze or check the code quality like into really optimistic. Even if it's really bad, even if it's really bad, I just like, okay, so I can just refactor it, and that's kind of like problem I just knew that I just somehow focus on the implement rather than checking out the code quality. Like it has to be like, of course implementing has to be first, but the checking the code quality has to be somehow remain and somehow be balanced, because you're able to eventually put into refactor time more about if you don't check your code quality. So this is really how my problem face before I put all of the logic in here. So like the B3 deletion and initialization, the part is already here. So of course when I'm trying to implement the hard algorithm, which is like deletion, it was really hard to track of it, and I finally knew that it's really time to refactor a bunch of it. And after I refactor it, even though, and there's more issue that even though I refactor, I didn't think about like I didn't make some kind of like good code quality on the deletion part because it was really hard. I somehow think about just implement it and refactor it, and that leads the problem that caused some kind of latency of this code. I should have like merged this kind of branch into two weeks ago, but it's already be there. So this kind of general how I think. Um, like you should like check vividly the code quality while implementing. You should be like doing critical thinking that your code sucks and you should somehow develop while making it. So and this is kind of about software engineering, and now next is like some kind of B3. My deletion operation. Um, Before it was like just checking the page children. If the page children is the leaf operation and do whatever stuff, but I don't like those kind of things. So I make it like recursion using parent page. After search the page, if I found it, return it. If I didn't found it, do the recursion to the next children. And if I found leaf operation, and if it is leaf operation is page underflows, and I do some kind of borrow thing. If I can borrow from the siblings, so this are actually the function that balance from borrow from the siblings, which means that it will cause underflows anyway. I just somehow make a balance from borrow from the siblings, and after that I search in the parents, search in the page, and I do the recursion part. I just traverse in the deletion tree, deleting tree. And next, so next part is that also, if it's not, I cannot borrow, I somehow balance via merge siblings. It's not really the merge siblings. It's rather say merge via pulling the parents. I think I have to refer to this balance from merge siblings, rather from pull parent merge siblings. But I think the borrower name is really kind of abstract. I just have to refer to it. So balance from pull, balance from borrowed, balance from pull parent merge siblings. So somehow I update the code. I do this to the same stuff what it does. Okay. So all of the like balancing logic is in this part. Balance from the borrow from siblings, which also means that I have to get from the child siblings. Now, if the parent pages, and if I can borrow from the siblings, I'll care from the children, and if the parent page with the already borrowed can that borrow from the children, I somehow extract the borrowed part and I put into children. So this is how I like make it. So the all of the like logic is split into some kind of functions to make it like have some kind of like their own responsibility. Yeah, so this is really hard. So even assign borrow operation is really pure operation that you extract the key in the page and you borrow it and you put into some kind of children or the parent. So descent borrow operation is ascend is going to bottom to top, and descent is bottom top to bottom. So even the get child sibling indexes, I think I have to change it like this. Never mind. Indexes is kind of pure that what it does is it just check the page of it and it just decide which one is the siblings. Because somehow if you're like leftmost node, child node, you don't have left node. So you have to get from the right sibling, so you have to make a left sibling as a no value. So those kind of things, so the responsibility of the get child sibling indexes is that it checks, it validates some kind of what siblings have to be borrowed, and it checks the absolute the child index based on the sibling index based on the parent index. So those kind of logic is kind of hard to track. So I think I just somehow implement it. So I think this is it. Have a nice day next time. Bye bye.